In this video, I'm going to discuss the object-oriented programming concepts known as encapsulation and abstraction. And so I'll start with encapsulation. So encapsulation is the packaging of data and behavior, so behavior usually referring to methods, into a single unit, such as a class, and controlling access to it. So, encapsulating it so that you're controlling the access to it. And so to encapsulate, we have the access modifiers, which I briefly touched on in the previous video. We have constructors, which that kind of goes along with these access modifiers and getters and setters, where getters and setters is the other sort of form of encapsulation. And so the access modifiers, so last video I discussed the public, private, protected, and internal. So the public is another class in the same namespace can use anything marked as public, where only the class in which the field or the method marked as private has been declared can use it. Protected means that that classes that inherit it can use it as well within the class. And internal means that the same assembly, which is usually thought of as just the stuff saved in the same directory or folder, can use it, where the more, I guess, technical term for that is a .dll or .exe created by compiling one or more .cs files, where the .cs files are the files that actually save your code into them. Then we also have protected internal, which is a combination of protected and internal. You can access the protected internal member only in the same assembly or in a derived class in other assemblies. Then private protected means that you can access members inside the containing class or in a class that derives from a containing class. So they're kind of a mix of protected internal or private and protected. Then this table right here, which comes from this website right here, just kind of shows what each of these are. So we have the public, the protected internal, private, protected, and private. And so this just says within class. So any of these can be used within the class in which they are declared. Then we have derived class here, so private can't be used in the derived class, non-derived class, so like the protected, and private can't be used. So derived class of a different assembly, only the public, protected, internal, and protected, and then the non-derived class of a different assembly, only the public. So we can see that the public here is sort of the most open for other code to actually use it, where private is the most closed off from that. And so these, so different things have different defaults for these. So if you don't actually declare one of them, it will just give the default for it. So the default for classes, properties, and methods is always the most restrictive access modifier that can be applied to that kind of thing. So for class, the default is internal. For a field or property, it's private. And for a method, it's private. And so I made this table here that kind of shows, so it shows the default in this column and then what all is able to be used here in this column. So classes can be public or internal. Properties can be pretty much any of them. Methods can be pretty much any of them. Enum and interface are both public. Struct can be public, private, or internal. So we can use constructors to hide the attributes, and then we can set the values for them using the constructors. So the other part of encapsulation that's important are the getters and setters, which I touched on in the previous video. So we can make these fields here, like the name and raw score, and then these properties here. So this name with the lowercase n is now, you return the uppercase n name here when you use this lowercase name here. So it'll return this. So that's the read property. Then the set property is the write property. So the name will equal this keyword value, which just means that if you set this lowercase name equal to some string here, so it's a string type, it will actually turn this uppercase name here into that value. It'll set the uppercase name into that value. So the thing to notice here, the uppercase ones here are both private, but using these public properties like this, we can actually turn those into essentially public. I mean, that's what having this get and a set here is doing, is essentially turning the name and raw score up above here into public. But they could be set, for instance, to read only by using just the get keyword, or write only by using the set keyword. So if we instead did it like this, where this had just the get, so it is read only, and this has only the set, so it is write only. And so the getters and setters can also allow for pre-processing of the data. So you can actually process data using it. So here we have this private field called letter grade, which is just a character data type. And so if we go down here, what we see is that the get here, so we're using this uppercase raw score here. So that is this one, which is set by this lowercase raw score here. And so the uppercase raw score takes on the value assigned to this lowercase raw score. And so then the program will look at the raw score for the particular object, and if it's greater than or equal to 900, then it will set letter grade through this lowercase letter grade. It'll set this uppercase letter grade. Well, it doesn't set it, it gets it. This is a getter here. And so the letter grade is just equal to the value for the lowercase letter grade. But when we attempt to get the letter grade, it's going to, instead of just spitting out some letter, it's going to look at the raw score here, the raw score field up here, and then it's going to spit out some character here depending on what the raw score is. Then we can use this down here. So this is a constructor of the student class to give the names and raw scores. So we can assign the uppercase name and uppercase raw score using this constructor right here. So if we use the constructor like this, so we're using the constructor and putting in the string type here and then the integer type here, so the name and the score, then it will print out A for Alice and C for Bob. And so we can look at that here more concretely. So this is essentially just the same code as I was just showing. So we have the student class here, and it has these private fields right here, and then we're just setting name and raw score. Essentially we're turning them public by using these getters and setters here. But then for this lowercase letter grade here, we are looking at the raw score here of 900, 800, 700, so on and so forth. And then when we sort of try to get the letter grade here, it will give us these characters here, and so we can look at that with this program here. So that's what I have going on right here. This is pretty much this what I showed here, and so we can print this out. So if we run this program, we get this. So we see we're just putting in this 980 and this 750 for Alice and Bob, and it gives us these characters right here for their grades. And so that is what this part of the code is doing for the getter on here. And so the take-home message is just that we can use the getters and setters like this to sort of control access to these private fields here, but we can also use it for doing some data processing. And so those are the ideas in encapsulation. So the next thing we're going to look at is abstraction. So this is using classes and interfaces which declare fields, properties, and methods that are then to be inherited by child classes. And so the main idea here is this abstract class. And so an abstract class is one that it can't be used to create objects, and we don't actually put like bodies in with the method. So up here we declared this class elements as abstract and this method here as abstract. And so we see we put the semicolon here and we don't declare any body for this method. But anything derived from this elements class must implement this reacts with method here. So we are declaring this in the abstract class, and anything that inherits this elements class here will be forced to implement this reacts with. And so it's in the child classes that we actually give those things bodies. And so we see we have some 1 to 2 inheritance here. So we have oxygen, which is inheriting from elements, and hydrogen, which is inheriting from elements. And then we have these the body for the reacts with, and so we have to use the override keyword here to override this abstract class up here. And so we are then declaring bodies in these here. And so again, what we cannot do is actually instantiate the elements class because it is abstract. And so we can't instantiate that that way. So we will look at the abstract classes here a little bit more concretely. And so this is similar to what I was just showing, but I've sort of embellished on it a little bit here. But what we have, so this elements class up here is our abstract class. So we see that it's abstract. It's declared as abstract. Then we have this electrons here, which cannot be abstract. It cannot be abstract, but can be declared in abstract classes. So we're declaring it in this abstract class, but this field itself cannot be abstract. However, this property here can be declared abstract. So this thing here that has the getters and setters in it. And so again, we just put the get and set here. We don't actually declare a body for this because it's abstract. Then we also have this abstract method here. So we have this public abstract method that has string return type. It has an integer parameter and a float parameter here. So I'm just using chemistry here because, well, I'm a chemist, so I'm just kind of nerding out while I nerd out here. So we have int for valence and float for electronegativity. Then so we see here I have this child class, which is oxygen, and we see that it is inheriting from elements. And so this child class here, oxygen, is forced to implement everything that we have up here, at least that was abstract anyway. So we see what I have going on here too is I have new public int electrons. So the keyword new is hiding the field inherited from the abstract class. So it's essentially saying that this is a new thing called electrons that is not the electrons from the parent class there. And then here, see, we have the property, which is the lowercase electrons. And so one thing to notice here, I have the getters and setters using these lambda operators, which is just the equals greater than sign. So it's supposed to look kind of like an arrow. And so we're just using get and then the arrow to electrons and then set electrons equal value. So the uppercase electrons equal the value that we set the lowercase electrons to. Then we see here I'm declaring some new properties here. So I'm saying that it has valence electron 6, so oxygen has 6 valence electrons, and its electronegativity, which is this En here, is 3.5. And then I'm overriding this method here. This reacts with method. So I'm using the override keyword here, and then using the same return type in these same parameters right here. And I did this 2 more times with hydrogen and with helium. So the main thing to notice here is in this one I use this form of the get and set with the curly brackets. So up here I used it with the lambda operators, and down here I used it with the curly brackets. But these mean the same thing. They do the same thing, but they just look a little bit different. Then down here I have helium. And so we see that this has valence 8, and for all of these, the reacts with has that if the valence is less than 8, then this will allow for a reaction. So it forms a covalent bond if our difference in electronegativity is less than hydrogen object, an oxygen object, and a helium object here, then we can use the reacts with methods here using the valence and electronegativity for each of these. And so if I run this, we get this. So this out? Well, I also have this to, so I'm just doing toString on this object. It's just going to print to string what the class of that object is. And so if I run this, we see false, true, and hydrogen. So stu3 here is not equal to D, which is an object of the hydrogen class. So that is false. D equaling D, that is obviously true. Then right here, us that those are equal to each other. And so things like equals and toString, which we see here, the equals and the toString down here are methods that are inherited by every class. So these are things that can be used by every class. And so the last thing I wanted to talk about are the generics. And so we can actually make classes and we can make methods and so forth that have generic data types. And so essentially what that means is we're not into it. And so compiler will pick up on the data type based on what you are using. But now we put p value here, then we instantiate it will turn this object, it will turn this into string and this into int types as well. So if we have something like this, so in angle brackets, but this in the this for what we have in here. So let's look at I have this one up here, which is just that first thing I was looking at where we had the T right here, and then this key value pair, T value. So if we go over here, we can uncomment this out right here. And so we see we're declaring one object with int and one with string, this one with int string, and this one with string int right here. For the different objects. So this one's using the int store, and this one the string store for the string type. Then this one I just call it KVP1 and KVP2, but we see this one has the integer for the key and the string for the value. String for the key and the integer for the value. Then we have this non-generic class right here, and so we see that this is outputting a generic array right here. It's taking these three generic right here, and then this generic array here, and printing it out. And so we can look at that over. So we will uncomment this out right here. So we have our non-generic class, which I'm just calling my class 1 here. And so in this first part here, I'm using string for my items. So these are strings that will be input into here, then a string which is what will be returned from this. So it's picking up. The compiler knows that because I am doing this as strings and putting strings into here, and then setting this string array equal to the method, which will give this as the return for that. And then down here we're doing the print method on this array, and so that will pick up that array. Whereas down here we are doing these numbers here as the parameters, and we are using an int array here as the return type, and so then we are putting an integer parameter into this print method here, which takes this generic array right here. And so then we can run this, and it gives this. So so we put for this one you mad bro into the array, and then printing out each one of those, so we get you mad bro. Then this one down here we did 4, 2, and 0 into the method, then printed it out, so we got 4 here. But yeah, those are the generic types. So we have these generic, and we can do these generic methods as well. And so yeah, those are the ideas of encapsulation and abstraction. So remember, encapsulation has to do a lot with these access modifiers and these getters and setters, whereas abstraction has to do with these abstract classes, abstract methods, with using interfaces, this object class, and these generics. So those are sort of the main things that have to do with object-oriented programming. But anyway, I hope you found this video helpful, and I will see you in the next one.